Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss about the topic linear differential equation of nth order with constant coefficient. Okay. In last videos, we have discussed in detail how we can solve the linear differential equation of nth order with constant coefficient. So we want to discuss the complete solution of linear differential equation of nth order with constant coefficient. So we find complete solution y is equal to complementary function plus particular integral. That is the general method of solving to any linear differential equation with constant coefficient. Y is equal to CF plus PI. But already we have discussed about complementary function. There are only 4 types to find out the complementary function of any differential equation, linear differential equation with constant coefficient. Okay, so I have discussed in detail in last videos how we can find complementary function of a given linear differential equation with constant coefficient. But in this topic we will discuss about particular integral of a linear differential equation with constant coefficient. How we can pi means particular integral of linear differential equation with constant coefficient. So the solution of a linear differential equation with constant coefficient in 2 parts. The solution divided into 2 parts. One part is complementary function and other part is particular integral. So total solution is complete solution of a linear differential equation with constant coefficient is y equal to CF plus PI. Complementary y is equal to complementary function plus particular integral. Okay. So now we want to discuss about in detail particular integral. How we can find a particular integral. Basically, particular integral of a linear differential equation with constant coefficient depend on the function is given on right hand side of the given differential equation. But in general equation on right hand side there is a function is q. Q is general function. Q is the function of fx. Q is the function of x. X is independent variable in our differential equation. Then Q is the function of x. Maybe any other variable is an independent variable. Suppose in our differential equation there is t independent variable. Then Q is function of t. So there are several types to find out particular integral of given differential equation. It is depend on Q. So one by one cases we have discussed the particular integral, how we can find particular integral in different functions. Linear differential equation of nth order with constant coefficient is given as below. I am here showing a nth order differential equation with constant coefficient and first degree. Nth order and first degree linear differential equation with constant coefficient. So I am writing in equation 1. This is general linear differential equation of n order with constant coefficient. In right hand side is function is q. The introduction of this differential equation we have already given in last video. So where p1, p2, p3 are numbers. numbers means are constant, and q is the function of x, because here x is in the differential equation each derivative with respect to x. So each derivative has x independent variable. So q is the function of x here. But here we will discuss linear differential equation of second order with constant coefficient. We are taking here only second order differential equation with constant coefficient and degree is 1. Second order first degree linear differential equation with constant coefficient. So we are discussing only second order differential equation. Here q is the function is given on right hand side. In this equation, this one p1 and p2 are constant and q is the function of x here. Say q is fx. Q is different type of function here. Q is here e to the power ax. Q is here x square x to the power m. M is number. M is positive number. M is positive number. Okay. And q equal to here cos ax, cos ax, and q is sin ax. Okay. So there are separate. This is the algebraic function qx to the power m. X to the power m means any algebraic function. This is exponential function. If q is exponential function, then how we can find particular integral? And q is cos ax and sin ax. So there are separate cases arise here. If function is exponential, then that is case first. Function is algebraic, that is case second. Function is trigonometric, that is case third. So one by one we are discussing here how we can find particular integral if function are different. So here we are giving several examples of linear differential equation of second order with constant coefficients are given as below. Here I am giving three example A, example B, example C. These differential equation are known as a linear differential equation of second order and first degree with constant coefficient. Because every time we know that here dy dx differential coefficient multiply is number only, not here variable. Only numbers are occurs here. First d2 by dx2 there is one number. Multiply 1 only here. Here is 6 only, 6y. And the order is decreasing. From highest order 1 by 1 is decreasing up to y. There is only single y there. Here is 0 order. Here 2 order, 1 order, 0 order. 1 by 1. 2 minus 1, 0. This differential equation also can be written as in this form. Here d square y. D square y, we write here d square y. Second order, d2 over dx2. This is capital D. Or d square. Or d square y over dx2. This is d square y. Okay. D cube y over dx cube. This is d cube y. This is small d here. Small d. D cube y over dx cube equal to d cube y. D is the ordinary differential operator. Ordinary differential operator D. D is represented by d over dx. Okay. So we can write this equation d square y plus 5dy plus 10y equal to e to the power x. Y is common. Here y taking right hand side common. So d square plus 5d plus 10 into y equal to e to the power x. Similarly, this equation we can write a b equation. Same in type, right? bd square y plus 6dy and plus 10y equal to cos x. This is 10. 10y equal to cos x. So here y is common, d square plus 6y and plus 10 into y equal to cos x. Okay. So we can write this equation in this type. Similarly, next equation we can also write d square y plus 6dy plus 8y equal to x square. Y is common here. So now y is common here. We can write d square plus 6d plus 8 into y equal to x square. D square plus 6 d plus 9 plus 8 y equal to x square. In D is differential, ordinary differential operator of one order, two order. So here we will discuss in detail how we can find the solution of the linear differential equation of second order with constant coefficient. Main motto: to find the solution of linear differential equation of second order with constant coefficient. So d2y over dx2 plus p1, this is the general equation of second order differential equation of linear differential equation of second order with constant coefficient. So d2y over dx2 plus p1 dy dx plus p2 y is equal to q. Q is the function of x here. So this is equation 1. Now solution of 1, we use here method y is equal to cf plus pi. This is cf, complementary function plus particular integral, that is complete solution. So I am telling you, every linear differential equation with constant coefficient and function of q in right hand side is given, then complete solution is in two parts. One part is complementary function, other part is particular integral. For complete solution of given equation, y is equal to cf plus pi. CF means complementary function and plus particular integral. Okay. So we have already discussed about complementary function here. Now we want to discuss our particular integral. This video is being focused on particular integral. We find out pi, every function case. So here we will discuss second part of solution. Second part of solution, that is particular integral of linear differential equation with constant coefficient. To find particular integral of 1 is given last equation, then q is not 0. To find particular integral of 1, then that is the must property. Q is not equal to 0, means q is any function. Q is given some function in our differential equation. If q is 0, then we cannot find particular integral. Okay. So d2y over dx2 plus p1 dy dx plus p2y equal to q. This is equation 2. Formula for particular integral we write here. This is the basic formula to find out the particular integral of any differential equation with constant coefficient. So pi is equal to, writing this formula, 1 upon fd into q. In denominator is function of d. Our equation write in function of d in y is equal to q. This is the equation of the function. Function d and y equal to q. Any question is given in this form. So here fd is function d. We are taking in denominator of the particular integral. Numerator is 1 and q is the function of x. This q function operate y differential operator this. This is equation 3. We will discuss here several cases depend on given function q in RHS of the question, and also we solve problem based on case 1. So case 1 is, what is case 1? We are taking here this q function. This is exponential function. Q is a exponential function. k is here exponential function e to the power ax. Same this standard function e to the power ax means e to the power 2x, e to the power minus 2x, e to the power x, e to the power minus x. This type of function is exponential functions are there. Case 1, if q is e to the power ax, then how we can find the particular integral? So here we will discuss about the solution on given q is equal to e to the power ax, where a is constant, may be positive or negative. A may be positive or negative. Now apply formula of pi. We are using here formula of pi 1 upon fd into q. So pi is equal to 1 upon fd into q. Putting value of q here. Q is the function in our question. Q is e to the power ax, exponential function we are putting here. So here apply condition 1. We are taking here condition. Condition 1, in each cases there are conditions. So here condition apply condition 1. What is condition? Now here putting d equal to a. D equal to a, then fa is not 0. How we can put here d equal to a? So we write here d of e to the power ax. This result a e to the power ax. Ax cancel, d equal to a. D square e to the power ax. This result is a square e to the power ax. D cancel, e to the power ax cancel means d square equal to a square. Means d ka whole square equal to a ka whole square means square d equal to a. So anyway we find out the del d equal to a. D equal to a. If exponential function are there, then after differentiating we get d equal to a. So putting d equal to a, then fa is not 0. This is the condition. Putting here d equal to a. This is fd. Function is here fd. So putting d equal to a. D equal to a putting here. Then fa is not 0. Then if integrating pi. Pi is complete. Here pi particular integral is complete. I want to solve one problem based on this topic, this case. If function of q is e to the power ax. So here problem 1 based on case 1. Q is e to the power ax, but fa is not 0. This is the condition. Fa, function of a. Fa, we have fd. So fa is not 0. Now problem is this, d2y over dx2 plus 5 dy dx plus 5 dy dx plus 6y equal to e to the power x. Now I am writing here d2y over dx2 is d square. 5 dy dx is 5d plus 6 plus 6 here. Y equal to e to the power x. So now first of all, the solution of y is equal to here cf plus pi. This is complete solution. Solution of equation this one in two parts. So first part is part 1. Now part 1 is complementary function. Complementary function. Function CF. First we find out CF of the given equation. So here we discuss CF. If we find out CF, then putting right hand side equal to 0. d2y over dx2 plus dx2 plus 5 dy over dx plus 6y equal to 0. Equal to 0. Here q equal to putting 0. We find complementary function, then putting q 0. Right hand side taking 0. So this equation can write this d square plus 5d and plus 6 into y is equal to 0. This equation 2. Now putting here d equal to m and removing y. removing y from 2. Then we get here m square plus 5m and plus 6 equal to 0. Finding roots of m. Finding roots of m, so m square plus 3m and plus 2m plus 6 equal to 0. Now m is common, m plus 3 and plus 2 common, m plus 3, this equal to 0. M plus 3 and m plus 2 and this equal to 0. So now here if m plus 3 equal to 0, then m equal to minus 3. If m plus 2 equal to 0, then m equal to minus 2. So roots of m are m equal to minus 3 comma minus 2. These are roots. So now CF formula for formula for formula for roots are different. Roots of n auxiliary form are different. Auxiliary form are different. Okay. So m equal to here m1 and m2. So m equal to here minus m1 equal to minus 3 and m2 equal to minus 2. So formula is CF is equal to C1 e to the power m1x plus C2 e to the power m2x. This is formula for CF. So here CF is equal to here C1 e to the power minus 3x and plus C2 e to the power minus 2x. This is complementary function. This is complete complementary function. This is complete complementary function. Complementary function. Complementary function. CF. We have find out CF of the given differential equation. Now, next we find the particular integral PI. So PI is equal to 1 upon FD into Q. 1 upon FD. FD means D square plus 5D and plus 6 into Q. Q is e to the power. What e to the power here? E to the power function is e to the power x only. Q is e to the power x. Q equal to e to the power x here. So we write this formula 1 upon FD into Q. So now putting D equal to, compare here e to the power ax. So here comparing this and this, a equal to 1 here. A is 1. Q is e to the power x in our question. Q is e to the power ax in formula. So comparing this. So a is 1. Here a is 1. So I am putting 1 upon FD means F1 into Q e to the power x. This equal to putting I am 1 upon 1 ka square plus 5 into 1 and plus 6 e to the power x. 1 upon 1 plus 5 plus 6 into e to the power x. But FD putting D equal to A. Here putting D equal to A. FD equal to FA. FA means F1. D equal to A equal to 1. So FA is not 0 here. So this is not 0. 1 upon 12 e to the power x. This is particular integral PI. Okay. Here denominator is not 0. Denominator of PI, particular integral, is not 0 means FA is not 0. So this is complete PI. Now solution, complete solution, complete solution of question. Given differential equation, given differential equation d2 by equation d2 over dx2 and plus 5 dy over dx and plus 6y is equal to 0. This is equal to e to the power x. So y is equal to complete solution cf plus pi. So y is equal to cx c1 e to the power minus 3x plus c2 e to the power minus 2x plus 1 upon 12 e to the power x. This is y. This is complete solution of given differential equation. Complementary function plus particular integral. So I am telling you, if q is e to the power ax, then in particular integral formula is 1 upon ft into q, and fd putting d equal to a. In our question particular solution putting d equal to a, then we are putting fa, but fa must not be 0. Fa not must be 0. Then particular integral is complete. So I am giving here okay. Now I am giving next example depend on this question here. D2 problem 2. Solving problem 2 based on case 1. Based on case 1. Case 1. I am solving one more problem. Case 1. So what is problem here? D2y over dx2 plus 7 dy over dx and plus here is 4 dy dx plus 4y equal to e to the power 2x. This is question. Now solving this, solve the question here. So solution, I am start solution here. First of all, writing here d2y over dx2 and plus 4 dy over dx and plus 4y is equal to e to the power 2x. This is question 2. Okay. So now here I am writing this equation, this d square plus 4d and plus 4 into y is equal to e to the power 2x. This is equation 3. Now first of all, first we find complementary function CF here. CF we find first, we find CF, then Q equal to putting Q equal to 0. Q taking 0, right hand side taking 0. Then our question is d square plus 4d plus 4 into y is equal to 0. This is equation 4. Right hand side taking 0 here. Okay. When we are writing q equal to 0, then we can find function complementary function. Otherwise not. So here putting d equal to m in 4, then we get an auxiliary form. Then we get an auxiliary form of 4. Auxiliary form of 4. Then our equation and y remove. Removing y. Removing y. Then our answer is m square plus 4m plus 4. This equal to 0. This is auxiliary equation 5. Now factorizing 5. Factorizing equation 5. Factorizing equation 5. So here is m plus 2 ka whole square. this equal to 0. So m plus 2 into m plus 2. So m equal to here minus 2 and minus 2. So roots are equal. Roots are equal here. So we write here formula CF is equal to C1 plus C2x e to the power mx. This is formula. So CF is equal to C1 plus C2x e to the power minus 2x. This is complementary function. This is equation 6. C1 plus C2x e to the power minus 2x. This is formula. E to the power minus 2x. Okay. E to the power mx. So now finding particular integral. Second part of the solution. Second part of the solution is pi. Particular integral equal to 1 upon fd and into q. So 1 upon fd, d square plus 4d and plus 4 into e to the power 2x. Putting here d equal to 2. What fd equal to f2 is not 0. So our answer is 1 upon here 2 ka square minus 4 into 2 and plus 4 into e to the power 2x. Now this equal to 1 upon 4 plus 8 plus 4 e to the power 2x. So here is 16 e to the power 2x. This is pi. This is complete pi. Because here fd equal to f2, this is not 0. Denominator is not 0 of this question. So there is complete pi. So now complete solution is y is equal to CF C1 plus C2x e to the power minus 2x plus 1 upon 16 e to the power 2x. Okay, this is complete solution. Pi is equal to here C1 plus C2x e to the power minus 2x plus 1 upon 16 e to the power 2x. This is answer. Now next, I want to discuss of same if q is e to the power ax, then case arise second. So here we are taking second case 2, if q is e to the power ax. What is the condition here? Condition here, when we putting d equal to a, then function fd equal to fa, this must be 0. So I am showing here where a is constant, may be positive or negative, same result here. Now apply the formula. Pi is equal to this formula. Formula particular integral 1 upon fd into q. This is d. 1 upon fd into q. This is the basic formula of particular integral. fd is the function in d. So here we write pi equal to 1 upon fd q. Q is here e to the power ax. I am writing q here, given that e to the power ax here. Now apply condition 2. In last question we have applied condition 1, where here apply condition 2. What happened here? Now here putting d equal to a. D equal to a in our question. Then fa equal to 0. Fa means the denominator of the pi. Denominator of the pi must be 0 here. Then processes change. Then if, then pi is not complete here. Particular integral is not complete. So now what happened next? Again apply condition 3. fd is 0, then next condition apply. Now apply formula pi equal to 1 upon fd into q e to the power ax. So what happened here? So we are doing here, this is exponential function. Exponential function taking left side. We are writing this function left side equal pi equal to this multiply 1 upon fd. So I am writing this e to the power ax is any number. So and I am writing here 1 plus fd plus a into 1. Here making binomial function, binomial theorem. Yeah, binomial, apply binomial theorem. Here apply binomial theorem. And function becomes 1 here. Because the total function, total exponential function to here left side of the pi. And here is 1. And d convert d plus a. D convert in d plus a when function goes to left side. Okay. So here making binomial theorem, apply here binomial theorem. How we can apply? E to the power ax and this fd plus a taking in numerator. So fd plus a we are writing in numerator, fd plus a whole to the power minus 1 into 1. After expanding this we get answer. But here we are writing differentiation of e to the power ax is a e to the power ax. 2 time differential of e to the power ax is a square e to the power ax. Differentiation of 1 is here 0. Differentiation of x is here 1. Differentiation of x square is here d square 2 times, this is 0. Differentiation of x square 2 times is 2 x square, this is 2. So these are different, this is differentiation with respect to x here, derivatives. So now d1 is 0, dx is 1, d square x is 0. Now problem 1 based on case 1. Q equal to e to the power ax. Q is equal to here, Q is equal to here e to the power ax. But fa is not 0. Fa is not 0. What happened? So we will solve here this type of problem which based on cases 2. Case is 2 here. Case is 2. Problem 1 based on case 2. So what problem here? I am writing here d square minus 6d and plus 10y is equal to e to the power minus 2x. This equation 1 and this equation 2. Now first, finding solution y is equal to cf plus pi. We find two parts. We find two parts in our solution. First part is complementary function, second part is particular integral. So in complementary function, to find CF of 1, then putting Q equal to 0, then putting Q equal to 0, then putting Q equal to 0 in 1. So this one is becomes this d square minus 6d and plus 10 into y removing and y removing from 1, y removing this equal to 0, putting d equal to m and y removing. So here putting d equal to m and y removing. So this equation m square minus 6m plus 10. Here y, putting d equal to m and y removing. Putting first of all q0 and putting d equal to m. putting d equal to m and y removing. Then we get this result 0. So here factorizing this here, m using formula. A is 1, V is minus 6 and C is 10. So m equal to minus b plus minus under root b square minus 4ac upon 2a. So minus b means 6 plus minus under root b square 36 minus 4 a 1 and c is 10. So upon 2a, 2 into 1. So here y is equal m is equal to here minus plus 6 plus minus under root here 36 minus 40 upon 2. So m is equal to here 6 plus minus under root minus 4 upon 2. So m equal to here 3 plus minus 2i plus minus 2 any I. 4 cut 2 to cancel 3. This is roots. The roots of an complement, roots of an auxiliary form are imaginary. Roots of an auxiliary form is imaginary. Roots are imaginary. So m equal to alpha plus minus I beta roots. This is alpha means 3 plus minus I. So alpha is 3 and beta is 1. So complementary function is formulas e to the power alpha x, c1 cos beta x and plus c2 sin beta x. This is formula. Complementary function. So I am writing here e to the power 3x, c1 cos x plus c2 sin x. Okay. This is CF, complementary function of 1 I am writing. Now particular integral, finding Pi. Pi is equal to 1 upon Fd. Fd means d square minus what here? 6d plus 10. 6d and plus 10 into q. So I am writing here Pi is equal to 1 upon d square minus 6d and plus 10. Q is e to the power Pi equal to 1 upon d square minus 6d plus 10 into q. Q means e to the power what here? E, what is e here? E here minus 2x. Here is minus 2x. This must be 0. There is must be 0. So this is not 0 here. I am putting here 3 bar 12 plus 12. And here is 4. So this is not here 0. I am writing figure here not. So this function is not 0. Here minus 2. Minus 2 means plus 12 and plus 4. 14. So here this is not 0 here. This is not arise in this case. So I am writing here Pi. Finding Pi here. 1 upon this here. Minus 2 ka square minus 6 into minus 2 and plus 10. And this e to the power minus 2x. So this equal to I am writing here plus 4 plus 12 plus 10 and e to the power minus 2x. So here I am writing 4, 12, 4, 16 and 26. 26 e to the power minus 2x. This is Pi. Here Fd means Fa is not 0. So case first arise here. Case first arise here. Case first arise here. Fa is not 0. If Fa 0, Then we apply case second. Now I am writing next question, that is for case. For case second, problem 1. I am writing here. d2y over dx2 and minus 6 dy over dx. Okay. So here minus 2 ka square and here 2 ka square 4, 6 2 ja 12, 2, 2 ka square. Suppose 1 here. I am writing 1 minus 6 plus 5. Writing minus 1 plus 6 minus 1 1 and plus 5 by here. Okay, this one. Plus 5 equal to e to the power x on t. Putting here 1 minus 6 plus 5. 6 minus 6 is 0. Correct? This is question is correct. In case 2. So I am writing here d square minus 6d plus 5 into y is equal to 0. This equation 1, this equation 2. Okay. This equal to e to the power x. Now, first of all, we find first part of the solution. So first part of solution is CF, complementary function. Complementary function. We find CF, then putting d equal to m and removing y. Putting q equal to 0, then putting q equal to 0. If we find CF, then putting q equal to 0. Right hand side taking 0. Then our question convert this d square minus 6d plus 5 into y is equal to 0. This is equation 3. Now putting here d equal to m and removing y from 3. Then we get auxiliary form. Okay. Auxiliary form. So now here m square minus 6m plus 5. This must be 0 equation. Which equation this? 4. This is 4 equation. Now factorizing this. So m square minus 5m and minus m plus 5 equal to 0. Factorizing. Factorizing here. Factorizing. Then here m common, m minus 5 minus 1 common, m minus 5 equal to 0. M minus 5 and m minus 1 equal to 0. So m equal to 1 and 5. Roots are different. Different here. So formula for CF, C1 e to the power m1x plus C2 e to the power m2x. So C1 e to the power x plus C2 e to the power 5x. This is the CF, complementary function. This is equation number 5. Okay. Now PI, particular integral, this equal to 1 upon fd into q. This equal to 1 upon fd. Fd is d square minus what is fd here? 6d plus 5 minus 6d plus 5 and e to the power x here. So now in case 1, putting d equal to a, putting here d equal to a equal to 1. But fd is not 0. Fd is equal to 0. Then case second. So here I am putting here 1 upon this is pi 1 upon d 1 ka square and minus 6 into 1 and plus 5. So this here 6 minus 6. So this here 0. FD 0. We are checking here FD 0. So here this case second apply here. Case second here apply. FD is 0. We are taking here FD. FD means FD means d square minus 6d plus 5. I am putting here 1 ka square d equal to 1 minus 6 into 1 plus 5. So 6 minus 6 equal to 0. Okay. So FD is must be 0. FD here 0. Putting d equal to a equal to 1. So now case arises. This e to the power x taking left side. Then pi equal to e to the power x and writing here d plus 1 and minus 6d plus 1 and into 5 and here is 1 only. So now here e to the power x 1 upon d square plus 1 plus 2d minus 6d minus 6 plus 5 into 1 here. So here 2d and 6d minus 4d, d square minus 4d and 6 minus 6 is 0. 6 minus 6 is 0. So here d square minus 4d. Now problem is here pi is equal to 1 upon d square minus 4d. Here is e to the power x. Here is one function. So I am writing here e to the power x. D is common. So here is d minus 1. D minus 4 here. So here d minus 4. D is common. D minus 4 into 1. So I am writing here e to the power x and d. So here minus 4 is common. I am taking here minus 4 is common. So here is 1 minus d by 4 and into here 1. And I am writing here minus 1 upon minus 4d e to the power x. This is writing here part of integration e to the power x 1 upon d. And here I am writing 1 minus d by 4 whole to the power minus. And I am writing here minus e to the power x upon d. And here open binomial 1 plus d. Here is I am writing 1. So here is d by 4 plus d square by 16 and plus this. Here is writing 1. So here is minus e to the power x upon d upon 4d and into here is 1 only. Integration of d, here e to the power x upon 4, 1 upon d into 1. So integration of 1 is x minus x e to the power x by 4. This is pi. Okay. So complete integral y is equal to cf plus pi. This equal to y is equal to cf. What is cf here? CF is C1x C1 e to the power x plus C2 e to the power 5x. 5 minus 5 minus C1 is 1 and 5. So minus 5 here. Plus 5. And plus minus x e to the power x by 4. So this is complete pi of the given question in second method. Means FD here 0. When we are putting d equal to a, then denominator of particular integral that is must be equal to 0. Then exponential function taking left side in multiply of the pi, and there is one question constant function are there and we making here binomial, then we integrate this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.